For topic 5, we're going to talk about magnitude of vectors. So we already know that when we're dealing with vectors, they have to have magnitude and they have to have direction, magnitude being some kind of length for us, okay? So for us at this point, when we're talking about the magnitude, we're literally finding the length of this vector, okay? So just think kind of pretty generic stuff right here. So we, like always, have definitions, okay? So we have that the magnitude of a vector is the length of the vector. Like I just said, the magnitude should always be 0 or positive. Below is some information about vector magnitude. Okay, so some notational things and then some things that are just sort of, let's use the word algebraically kind of loosely, but things that are just algebraically so. Okay, so first of all, when we're talking about the notation, kind of symbolically, how would we represent this? You can use these bars. They look almost like absolute value bars, but be very careful. They're absolute value bars if what is inside is a scalar. They're magnitude bars if what's inside is a vector. Okay? So when we plop a vector in here, like vector v, these become magnitude bars. And then sometimes just to make sure there's no confusion with magnitude bars versus like absolute value bars, we can use these like double bars. So you'll see kind of like they look almost like absolute value bars inside absolute value bars, but it's the double magnitude bars. This also is just magnitude bars. Okay, so the way you can easily differentiate between just absolute value, well, let me write that a little bit better. Whoops, there we go. Is if you have a scalar inside, they're absolute value bars. If you have a vector inside, we're talking magnitude bars. Okay, so be careful. It's just all about what's inside. Vector inside, magnitude bars. And just know that you can see the double magnitude bars or just the single magnitude bars means the same thing. Okay, now once we've got that settled, hopefully that makes sense. We need to talk about a few just kind of like properties, things that are true. So magnitude has to be non-negative. Okay, so non-negative. And in the definition, we kind of stated that. We said the magnitude of a vector is the length of the vector. The magnitude should always be 0 or positive, okay? And that should make sense because we're talking about the length of a vector. So regardless of what direction this vector is going, it either is the 0 vector where it has no magnitude, okay, no direction, so it's just sort of the 0 vector, or it's a vector that has magnitude, okay? Now, if a vector has a magnitude of 0, that is going to be the case if and only if the vector is the 0 vector. And the 0 vector, denoted by 0 with like the little vector bar thing on top, this has a magnitude of 0 and no defined direction. Okay, so if you end up getting magnitude equals 0, then you know you're dealing with the 0 vector. Okay, now if we have the magnitude of the negative v or minus v or the opposite of v, it's going to equal the magnitude of v because remember that negative in front of it, it really just kind of changes the direction. It sends it in the opposite direction. So if we have v sitting here like this, well, the negative v or the opposite of v, it's going to have the same magnitude. It's just going to be in the opposite direction. So the magnitude is the same. Okay, so just remember when you have v versus negative v or opposite of v, they have the same magnitude, one's just in the opposite direction of the other, okay? And then finally, this last one, we can really kind of talk about the bars, absolute value versus magnitude bars. We're saying if we have the magnitude of some scalar times some vector v, we could rewrite that as the absolute value of the scalar times the magnitude of the vector, okay? So on the left right here, we're dealing with the absolute value of A. It's absolute value because what's inside is just some scalar quantity, okay? And we know it's a scalar mostly because we don't have the little hat on it and we haven't done it in that super bold print, okay? So we know that's absolute value bars because the stuff inside is a scalar versus over here on the right-hand side of this, we're definitely dealing with magnitude bars because what's inside is a vector. So just really, it comes down to what's inside. If it's a scalar inside, absolute value. If it's a vector inside, magnitude. Okay. So one more definition really quickly, and then that's really it for this video. This is just some properties. So the last definition is you can have something called a unit vector. A unit vector has a magnitude of one. A lot of times in math, we have units. Obviously, we have units like inches and miles and feet and kilometers and stuff. But other than that, generally when we talk about a unit, we're talking about something that equals one. So the unit vector is a vector that has a magnitude of one, okay? And it is denoted as follows, okay? So we will talk about unit vectors later. We're going to talk about component form of a vector, and you'll see some unit vector stuff there. But that's it. Those are just some facts about magnitude. Now we do need to kind of remind ourselves, where can I squeeze this in? Maybe over here. When we're dealing with the magnitude of V, okay, we're in a bit going to talk about like components of V. So we could say that the vector is going to have these components. We're going to call them A and B. We can find the magnitude from this with like a really easy formula. It's basically just the Pythagorean theorem. So we've played around with that a bit, but we're going to talk about it more formally in just a little bit. Okay. So that's magnitude of vectors. Nothing too crazy. We're just looking for the length of a vector, and they've got some properties we need to kind of understand.